on the code artifact. This is basically the code artifact part 2. So if you have not seen our previous video on the code artifact part 1, I will highly suggest you to go through that, in which we have discussed about the introduction to the code artifact. In this video, we are going to discuss more about the package management, and we are going to discuss regarding this package management, how it plays a very significant role in the software development, and then we are going to shift to the code artifact and see the relevance from that point of view. So if we talk about the package management, it is basically the process of handling the external software dependencies that a project relies on to function correctly. So think of this like the dependencies which our project might be having for the code to work correctly. So developer tend to use the functions, the classes which are pre-built, so that they don't have to rewrite the same logic again, and rather focus more on the business requirement, right? So the functions that they are using is actually rely on the these dependencies which they are using. So if they want their code to be working, those dependencies or the packages must exist. Then only the applications are going to work correctly. In modern software development, applications rarely exist in isolation. They often depend on a wider range of libraries and modules developed by other individuals and organizations. So this is a general trend now. You don't need to write everything from scratch. You can use the wide libraries which have already been written, and you can directly use those libraries, the code which has been written by some other individuals and organization, and make your application development much more faster. So this is a general practice which is followed now, and that is how why it makes it so important that we should have all our libraries and modules available with us all the time during the build phase of the application. Because if some of these libraries or modules goes missing during the build phase, then it will create the issue, and various bugs will be reported in the application, and it will not tend to work as desired. Okay. So a package manager is a tool that automates the process of discovering, downloading, installing, and updating these external dependencies. So if we look at a package manager, there are various package managers which are available. The main function of the package manager is that it should be able to discover, download, and install and update all these external dependencies which our project is using. So we should be able to document that, and rest it's up to the package manager on how it's going to download, install, and update these dependencies for making our application work. Okay. So the package manager has to ensure that the correct versions are required for the libraries are installed, avoiding conflicts and simplifying the development process. It is possible, suppose you are using a package, okay, like GSP servlet, so there can be different versions of the same package. So it is up to the package manager to ensure that the version which has been specified, suppose in the XML file, it has to pick up that version in case of the Maven. Okay, so that is how the package manager actually has to work. This is done to avoid the conflicts and simplify the application development workflow. Now, some of the popular package managers for different programming languages include NPM, which is basically a node package manager for JavaScript, Node.js projects. Then there is Maven, which is very popular for the Java projects. Then there is PyPI, which is Python package index for Python projects, and NuGet for .NET projects. Okay, so these are some of the most popular package managers. Now, package managers maintains a central repository of packages for each language, and developers can specify the dependencies they need in the configuration file. For example, in case of NPM, you are going to use package.json, while in case of Maven, you are going to use pom.xml file, where you are going to define all your dependencies, the versions which is required by your application, and then it comes down to the package manager to download those packages from the Maven central onto the machine on which you are going to run your application. So when a project is built and executed, the project package manager is going to automatically download the required dependencies and ensure that the correct versions are being used. Okay, this is what the package manager is responsible for. So now, if we talk about the artifact repositories, the artifact repository is a centralized storage location where all the storage artifacts like your libraries, modules, packages, binaries, etc. are stored and managed. These artifacts are typically the output of a build process and are used as dependencies in other projects. Okay, so this is what we discussed earlier as well. So basically all these artifacts, whether it's a library, whether it's module, package, binaries, whether it has been generated by our application or our application is using some previously written code, all of these needs to be stored in some particular process where my build tool can later contact and download all these packages which are required by my application during the build process and use them as a dependencies. Okay, now, if we talk about the artifact repositories, provide several key advantages. What are these advantages? First one is centralization. By storing the artifacts in a central repository, development teams can avoid the duplicating of the efforts and improve collaboration, right? So they no longer have to again and again download the same packages, keep in some location and work with it, because that can duplicate the efforts, right? So with the artifactories, generally you cannot duplicate the same artifact. It will already be downloaded and managed by the package manager. All team members can access the same set of dependencies, ensuring consistency across the project. So you don't have duplications and the repetitions in the packages, right? So this is the thing. The another thing is version control. Artifact repositories maintain multiple versions of each artifact, allowing the project to use specific versions which are needed. This ensures that the projects are not affected by the changes or updates in the external dependencies unless explicitly specified. This is very important because over a period of time you would see each of these artifacts getting updated, due to which the number of versions are being created. Sometimes when you update the version which is not required, because the version got updated, so it always try to fetch the latest one. But with the package manager you can specify the exact version, and then the package manager is only going to download that very specific version, not the latest version. Sometimes downloading the latest version can break the overall code, so that kind of issues can be resolved. You can test your application first and then download the specific versions, which helps us to reduce these kind of errors and thus help us managing the multiple versions of our artifact. Okay, next is security and access control. Repositories can be configured with access control to ensure that they are authorized users are only accessing those repositories under the projects can access by the artifacts. This helps to maintain the security and integrity of your software supply chain. Okay, so only the users which are authorized should be accessing or basically accessing those packages, and this is very essential. This should not be allowed to modify, it should not be allowed to override the packages, because that can provide the overall issues or the security vulnerabilities in your software supply chain. Okay, so there are various threats related to it. All these can be mitigated by the use of these artifactories. Next is caching and the performance. Repositories often implement the caching mechanism, which helps to improve the overall build and the deployment time by reducing the need to download the artifacts. Since you are storing them internally in your environment, you no longer have to download from the internet, which is going to reduce the time for your build as well, which is very important. If we talk about the code artifact as an artifact repository, so code artifact, as mentioned earlier, is an example of artifact repository which provides you the service is provided by the Amazon Web Services. It integrates seamlessly with the popular package managers, allowing the developer to use the code artifact as a central repository for their dependencies. Code artifact provides a secure, scalable solution for managing and sharing software artifacts in AWS environments. What this means is that code artifact, it can act as a centralized repository, so all your packages will be stored over there, and it automatically resolves all the dependencies, cache them. Then it can only be accessed through the IAM. You can use the IAM to manage the permission, the policies. So it basically provides you a secure, scalable solution. That is, if your artifacts start increasing and the storage is required, it can automatically scale that up. Okay, so you don't have to worry about those kind of things. Also, you can easily share if you are within the your organization is deploying using the AWS environment. You can easily share across your environment. So all these challenges with the artifacts, which are used by the different teams, including development teams, testing teams, like that, or the build environments, all of this can be easily managed. So the operational work overhead can be reduced by the use of the code artifact. By leveraging code artifact, AWS users can ensure that their AWS infrastructure and application deployments are consistent, secure, and efficient. So this is making your supply chain more robust, because then you are exactly sure what packages you have used, and it makes the overall build process more consistent. Every time you are doing the build, the same packages are getting used. Those packages are secure because you have one time you have downloaded it from the centralized repository. You don't have to download again and again. It's already in your cache, so you are using from there, so it increasing the security, as well as it's making the overall process efficient by reducing the time. Okay, it simplifies the management of the dependencies, enhances security and the compliances, because it can generate the audit trail, right? So every time someone is changing, those will be recorded in the trail. So this is also very important from the compliance perspective, and facilitates the integration with the other AWS services and developer tools. So ultimately improving the overall software development process. Okay, next is how to access the code artifact. So generally, there are three possible ways how you can access the code artifact depending upon what you are trying to do. So you can directly use the AWS management console, through which you can directly go into the code artifact and generally scroll across the packages and the dependencies. This can be used to share the dependencies across your teams as well. So if someone wants to download, they no longer have to request. You can directly create the users, provide them read-only permission. They can access those dependencies and look at the dependencies depending upon what role they are performing. You can assign the permissions using the IAM itself. Then another way of doing is through the AWS CLI. If you want to automate some job or some cleanup process or something like this, you can actually directly use the AWS CLI as well. You can use the access token and the secret access token for configuring AWS CLI, and then you can make the requests and you can directly access the code artifact and the packages over there with the help of CLI as well. This is generally used for the automation perspective. And the last one is through SDKs. Now SDKs refer to the software development kits. Now AWS SDKs are the libraries and tools that enable the developer to interact with the AWS services in their preferred programming languages. So you will see that whatever programming language that your organization might be using, whether Java, Node.js, or anything else which they are using, generally AWS SDKs are available in all the programming languages, and they actually handle all the session establishment. The functions are pre-written so that the developers don't have to rework them, right? All these have been pre-written. They can directly include and just call these functions to perform the actual actions which has to be done, and thus reducing the overall efforts from the development perspective, and improving the reducing the time and improving the efficiency of the developers to interact with these code artifacts and retrieve and use them whenever during their build process requires. Okay, so this completes our code artifact theoretical part in the part 2. In the next part, that is the part 3 of the code artifact, we are going to perform a hands-on lab from scratch, and we are going to see how we can create a code artifact repository using the AWS CLI itself. Okay, so that's all for the code artifact, and I will see you in the next video, where we are going to perform the actual hands-on on creating the code artifact and seeing how it stores the packages and then accessing it through the web console and as well as the CLI itself. That's all for this video. This is Ankit, and see you all in my next video. If you have not subscribed to our channel, do subscribe to our channel for more such videos. Thank you.